In our study, users first saw a world in miniature with a point of interest pin that indicated their target position and direction. Two landmark pins indicated positions they would need to recall after they transitioned into the target view. The user completed a multi-scale transition into the street level view indicated by the POI pin and had to recall the positions of the landmark pins. Then, the target building turned into a wireframe representation and highlighted a room in blue. The user completed a same-scale transition to travel inside the indicated room. Finally, the user had to point to their last virtual position on the street relative to their current viewpoint. With the object-based technique, the scene moves around the stationary user rather than the user moving through the scene. The virtual environment rotates and translates to align with the user's target heading before the viewpoint change occurs to externalize the mental rotation that would otherwise be required. The user remains physically and virtually stationary throughout to avoid perception of self-motion. The visuals of the environment components, such as buildings, are simplified to reduce clutter and emphasize the user's target position and orientation. The avatar technique previews the user's future pose through an avatar representation. An abstract avatar departs the user's body, travels to the target location, and assumes the target orientation before the user is transitioned there. The avatar's head and arms track the user's motion, and its final pose gives a third-person preview of the destination position and heading, supporting orientation. Because the user's own viewpoint remains stationary while the avatar moves, the technique externalizes travel motion and avoids visual vestibular conflict. The flying camera technique shows the user's travel path through a decoupled virtual camera feed to externalize the sensation of movement. A virtual camera flies along the travel path while the user watches its live feed on a flat, monoscopically rendered panel. The camera path shows the spatial relationship connecting the two viewpoints. The decoupled reference frame, restricted field of view, and monoscopic rendering reduce discomfort risk by limiting visually induced vection. The uninterrupted visual flow between positions maintains experiential continuity. Thank you for watching, and please refer to the paper for more details.